solving systems in 3 variables with 3 equations by elimination. When you're solving something by elimination, the words that should come to mind, at least my mind, would be cancel out, equals 0, and to get rid of. And this can be done by a number of methods. I tend to stick with adding, so I default to addition. So adding different equations together in the system. And it's important to note that there's more than one thing to immediately eliminate in the system. So when you independently practice, your partner could do something that you don't do that step first, and that's totally okay. So there could be more than one term to eliminate first. So let's look at some examples. And I'll do numbers 1 and 2 for you, 1 and 2. And then you'll do the rest on your own. I see here that in number 1, there are a couple of things that can get eliminated first. I could add the first 2 equations together because I see the opposite coefficients in the first part, or I can add the second 2 equations because I see the opposite coefficients in this part, and that's what I'm going to go with because I want to do as much as I can as fast as I can. So adding the first 2 equations together gets rid of 2 of our variables, and then I'll have just the one to solve for. And I'm marking off my free space so I can organize when I solve for each variable. And I say here that step number 1 that I'm going to do is to add the first and the second equations together. 4y minus 3z equals 1. When I add these 2 equations together, my z and my y variables cancel out, they equal 0, and I'm left with 1x equals positive 1. And that's the first part of my solution. And I can mark that off. I'm done with that. And then I'm going to use my x value in the easiest possible way to find another variable. And I see that the third equation is going to be the easiest. So step number 2 is to substitute into the third equation, negative 4 times 1 plus 4y equals 8. Well, 4 times 1, negative 4 times 1 is negative 4 plus 4y equals 8. And so, x is negative 1, so this would be negative 1. So this would be positive 1. And then I would subtract 4 from both sides. 4y equals 4, and so y equals 1. And that's the next part of my solution. And I'm going to mark that off. And so then the last part would be to use these 2 values to identify z. And I'll just use the first one because that's the easiest. So 4x minus 4y plus 3z equals negative 2. And we'll say 4 times negative 1 minus 4 times positive 1 plus 3z equals negative 2. Negative 4 minus 4 plus 3z equals negative 2. And this is negative 8 plus 3z equals negative 2. And so I would add 8 to both sides, leaving me with 3z equals 6. So 1z equals 2. And that's the last part of our solution. And so then when you solve systems by elimination, you want to write them as an ordered pair or triplet if you're solving in 3 variables. So our x value is negative 1, our y value is positive 1, and our z value is positive 2. And this is our solution. So let's get a note card and let's write these steps down as we solve them for the next problem. So this is solving systems in 3 variables by elimination. And the first step is to look for opposite coefficients. So step number 1 is to look for opposite coefficients. Opposite coefficients. And I see that my second and third equations have opposite coefficients. Negative 4x, positive 4x. So then I will add those equations to eliminate something, to eliminate one variable, at least. So let's add these equations together. I'm going to mark off all of the space that I have to work with. All of the space that I have to work with. All of this here. And I will add these two together as step number 1. Negative 4x minus 2y plus 5z equals negative 22 plus 4x plus y minus 5z equals 21. And see, there's another opposite coefficient right here. These are all addition, by the way, when I'm adding these equations together. So I add them down the columns, these cancels out, these cancel out, and I get a negative y equals negative 1. So divide by negative 1 on both sides, and positive y equals positive 1. And that's the first value that I've found in our solution. I'll use that value to substitute in and find something else. Now, there's not an equation where there's just one more variable that I can find. I'm going to have to substitute this into 2 equations so that I can add those together to eliminate and find another variable. So watch what I mean. This y here, I can substitute it into any of these equations, and I'm going to need to do that 2 times. So I'll pick the second equation, negative 4x minus 2 times 1 plus 5z equals negative 22, and so negative 4x minus 2 plus 5z equals negative 22 plus 2 plus 2, so negative 4x plus 5z equals negative 20 is the first equation I will use. And then I will substitute y into another equation. And I used the second one this time, first, second, third equation. And I'm going to use the third equation this next time. 4x plus 1 minus 5z equals 21. And so I subtract 1 from both sides. And our second equation is 4x plus 5z equals 20. And I see here I luckily have in my two equations two opposite coefficients, negative 4x, positive 4x. So we'll rewrite negative 4x plus 5z equals negative 20. And this negative 4x is the same. We'll add these two equations together. Our opposite coefficients cancel out, and we get 10z equals 0. So it doesn't matter about what z's coefficient is, right? Z equals 0, which is the second value we have found in our solution. And then the last value is the x value, so we will need to find the x value, and I'm going to do that above because that's the only space I have left. I see that it'll probably be easiest to substitute into the third equation. So 4x plus 1 minus 5z equals 21. And we know that z equals 0, so we can erase this and put 0. So 4x plus 1 equals 21, minus 1 on both sides. 4x equals 20, so x equals 5, and our solution is 5, 1, and 0 for our triplet. X equals 5. So as you go through the examples, the question I want you to consider is, why do we have to substitute more times into an equation in problem number 2 than number 1, and you solve the rest of the problems on these practice activities.